Chicago, but
it is Chicago.
Over to you. It is Chicago.
Yes, it's University of Chicago.
All
As one of the professors here mentioned, the best Oxford Rockefeller money can buy. It was established by John Rockefeller, so that's why. Okay, and right now it's much more, what's the word? Unhappy, I would say. It's cold and snow. And thank you for spelling correctly my last name. It's a challenge, I know. Okay, my title is a little bit more flowery. Adventures with large biomedical data sets, environmental exposure, and disease. And yeah, so just to give you some story, and I apologize, it's a little bit informal presentation. I started as a geneticist and then had long trajectory moving me closer to environment. And I can explain why. So a while ago, I was walking through Pushkin Museum in Moscow, and I came across this portrait of Princess Adelaide de Savoy on her wedding day. Okay, and interesting thing, she was married when she was 12, and by 26, she was already dead. And that's the time when some of us are struggling to publish the first paper. So question is why? If you go to history archives, apparently even royalty lived in a very different world at the time. So first her father-in-law, Grand Dauphin, caught smallpox and died. Then her husband became Dauphin of France and she Dauphine. And then she caught fever, which escalated in measles. She died in Versailles at the age of 26. And then Dauphin himself died 6 days later. And my point is that at 26, her life was finished because of infectious disease. And today in US, you see mode of pregnancy is at 29 years. So essentially what I'm trying to tell you is that environment drastically changed just in last few, well, decades, I guess, and even more so in hundreds of years. Okay, and as they say in Monty Python, now entirely different story. So I'm working with large data sets. I'm experimentally challenged. So I go to data safari. I visit exotic places, for example, Stockholm in December, and work with large data sets. You probably all know International Classification of Disease, do you? You do, right? So yeah, basically it's large collection of records, and for example, it's life of one patient, 15-year-old Hispanic girl, and for example, she had unspecified viral infection at age 6. So this kind of encoded data in time. And one of the biggest data sets that I have access to is insurance claims in US. It's 185 million unique people, 16 years, day level resolution, and we have daily diagnosis with geographic information. And just to give you a feeling how it looks, it's influenza in US from this record. Each frame is 1 week over 9 years. And you can see how influenza sweeps United States. It always starts somewhere in the south, and then it moves to the north. And I literally spent hours looking into this, and we have another paper which I wouldn't mention more. The data is very, very biased. It wasn't generated for research. So for example, if you look at psychiatric conditions, and not only psychiatric, you will see that yearly annual peak has some interesting dips, right? So this is week 1, 0, and this is week 52 of the year. And you probably can guess why. And basically it's Memorial Day, July 4th, Labor Day, Thanksgiving, Christmas Eve. So essentially in the cycle, we have not only biology, but also social, all kinds of social confounders. Okay. How much time did I spend? Sorry. I don't know if we have time for metaphor. What do you think?
You've got about 10 minutes or so, just over 10 minutes left.
Okay. So essentially how I think about complex disease and looking at genetics and environment. This is a real accident with a plane which crashed in the United States in North Carolina. It kind of flew into air, stalled, and crashed in something like 27 seconds. And then they started investigating what happened. And it turned out there were two reasons for this crash. Number one is genetics, quote unquote. Essentially, some cable that regulates lever at the tail was too tight, right? So it wasn't full range of motion. By itself, it was harmless, relatively harmless, because plane made many flights. And there was second reason, which I call environment. The plane was actually overloaded and out of balance. Thing is, at this time, they calculated load of the plane by counting passengers and multiplying by average weight. And in time, in the last 20 years, average American became approximately 20 pounds, so 9 kilograms heavier. So plane was actually much heavier than they expected. And essentially, phenotype catastrophe would not occur in the absence of genetic and environmental component. And normally in talks, I talk both about genetics and environment, but today I'll just talk about environment. Okay, environment is can of worms. Why is that? Because how this philosopher mentioned, there is unknown unknowns, right? We don't know what to measure. I hope you all remember him. Do you? So there are millions, billions, trillions of potentially relevant environmental factors. And as we heard in two previous talks, well, you can measure many, many things, but essentially in advance, we don't know what's important. Next point is that diseases are not uniformly distributed over space. For example, idiopathic pulmonary fibrosis in the US. Idiopathic is translated from medical speak. I have no clue why, right? And pulmonary fibrosis is when lungs are substituted with fibrous connective tissue, and essentially patient slowly drowns in lungs. But my point is that if you remember in US, biggest population is here in the East near New York. And the biggest kind of cluster of occurrences of this disease is in California. We don't know why. Now, psychiatric diseases. I'm not sure if you have seen cartograms before. Essentially, you treat map as a, I don't know, elastic thing, and parts which have more substance, in this case, bipolar disease rate, they would get inflated, and places which have few of kind of content, they will shrink. So you can see that bipolar disease is more prevalent in the mid USA and not so prevalent in South and the far North. And if you look at depression, as you can see, Midwest and the middle of the United States is quite depressed. Okay. And I always give credit. It's my brilliant associate Atif Khan, who did actually most of the work. And we also have collaborators, great collaborators in Denmark. Allegur Panaripol, he did actual analysis under supervision of Karsten Bocker-Pearson. And we published it in PLOS Biology a while ago. So what we looked at, we used US Environmental Protection Agency environmental indices. And they have essentially the idea that they have something like 76 substances measured in air. We took all these measurements, had principal component analysis, and sliced into 7 septiles, right? So you can see air quality by septiles here, probably good in the middle, not so good in California and East. They also had land quality, build quality, and so on. And we also used good weather days and bad weather days to account for how likely people are go to outside or stay at home. Okay, so the air quality is the main thing. And as I mentioned, it's septiles. As you can see, it's quite continuous across US counties. And you probably all know about mixed effect regression, do you? Or let's put it, do you want to know about this? I have a whole story about this first Fisher's paper, but we don't have time for this. Yeah, basically it's a Poisson process which generates disease cases, and the rate of this Poisson process, lambda, is linear kind of function depending on fixed effects, some intercept, and random effects. You can think about fixed effects as known knowns, contributions from parental genotypes, for example. And random effects are known, basically Ramsfeldian unknown unknown. Everything that we can't measure will go to random effects. Okay, and you can think about all this thing essentially as machine, black box. You put factor in one side and you get the effect on disease, predictive effect on disease on the other side. And the results. I told you about septiles, right? So basically that's the main result. For US, for bipolar disease, the strongest effect we see is for air quality. And remember that it's all measurements, they tend to be collinear. So the worst case, the worst septile for air quality has highest predictive rate for bipolar disease. And it's adjusted for population density, it's adjusted for status of insured, poor, urban, and for income. Are you still with me? You see, that's the problem with Zoom. You can't really see audience. Okay, so in US, we actually got quite decent, but not terribly large effect sizes, 27% increase for bipolar and 6 in major depression. But for Denmark, they had much higher resolution on environmental data, up to 1 square kilometer. And they had it in long, long time. And as you know, in Denmark, they know history of each person from birth to death. So they were able to compute exposure for each person during the first 10 years of life. And in Denmark, while it's much cleaner than US, because exposure was so well computed, effect size was staggering. So 162% increase in personality disorders, 148% in schizophrenia, 50% in major depression, and 29% in bipolar disorder. And all of those things were highly significant. Okay, and yeah, there was quite a bit of resonance in multiple languages. And I guess I'll save you some time. By the way, this is also Chicago. It's more like what it looks like right now. And I'll thank you at this point. Yeah, and we'll happily participate in follow-up.